All right, so parent functions. That terminology sounds familiar, yes? Remember talking about parent functions in Algebra 2? Should have talked about most of these that we're going to look at. Maybe not all of these. All these on this piece of paper, though, for sure. Yeah, all these on this piece of paper. The next piece of paper, there'll be one, probably just one new one, but it's not that big of a deal. But these are parent functions, and it says here, a function family is a group of functions with similar characteristics. The parent function is the simplest of the functions in a family. You must be able to recognize each of these functions along with their characteristics, okay? It's something that when you see the graph, in your mind, you should know what at least the parent function would look like when it's written as an equation, and vice versa. When you see an equation, you should know what the parent function looks like and be able to just sketch a quick little thing out to the side, okay? So first one, linear, you've been talking about lines for a long time, right? Lines have been around for a long, long time. So the parent function of a line is this one, okay? It's the simplest line that we have that we can graph, right? It's before any of the transformations have been made. And when you learn how to graph lines, I don't think anyway, at least they haven't in the past, I don't think they talk to you about the fact that like y equals mx plus b and things like that, that when you have those things, what's happening is your line's just being transformed. The same kind of transformations you talk about, that you started talking about in Algebra 2, where things shift left and right, up and down, it works the exact same way with a line. You just aren't taught it that way, and it's not quite as obvious because it is a line. Like when you stretch it, it doesn't look stretched necessarily, and things like that. But it's still exactly the same thing that's happening. Your function as an equation, since these are all functions, we're going to start with f of x equals, and what would this one be? X. F of x equals x, or y equals x is what you might have, So we've got f of x equals x. We'll write it as y down here. We've got this little, this line down, this space down here for us to make some notes about what's above it. But it's a function, so f of x equals x or y equals x. So when you substitute numbers in, when x is 1, y is 1. When x is 2, y is 2, and so forth and so on, right? And then if I have y equals x plus 3, right? That means your y-intercept is 3. We agree with that? So, we'd start here at 3 and we count our slope. But really, this line, as it is, just gets shifted up 3 units. That's all that's happening. Okay? We okay with that? So for each one of these, we're going to find these things that we need to know. Domain. The domain of the line. What's the domain of this line? Who wants to tell me? Okay, it's all real numbers, and that is a true statement. We're going to write it as interval notation. Technically, all real numbers is not a bad thing for you to say or understand, but that is set notation. So to write that as interval notation, how do I write that? Negative infinity to positive infinity. And then do I put brackets or parentheses? Parentheses. Okay, because we never include our infinities. Make sense? Okay, so what's our range for this then? It's the same. It's also all real numbers, which as an interval is going to be negative infinity to infinity. Okay, we good with that? Now, this is kind of another little side note here, is that sometimes when you write let me see if I can get to the end. Like, some of you write an 8 like that, or you might write like that, and even sometimes now and then I do that. So you can do infinity like this, or you can even do infinity like with 2 circles stuck together. But make sure you're not doing this. I've seen way too much of that, where literally there's a space between all of them. Infinity is not, or sometimes it's even worse. Infinity is not 2 zeros. Okay, I don't want there to be any misconception of that. It's like an 8 that fell over, kind of. A little stretched out. It's not exactly like that, but it needs to, if you're going to write it that way, which again, that's how I write my 8s sometimes. I just don't do that with infinity, but sometimes my infinities look funky too. But make sure it's actually a continuous thing that happens, right? That makes sense to you? Okay. So it's, every now and then if there's a little space, not the end of the world, but I feel like on some of the ones that I've seen, I think you don't know what you're writing. Maybe it's not even in this class, I've just seen it. Okay, so then I have to look at my x-intercepts. Where does this function cross the x-axis? At 0, 0, right? There's my x-intercept, right? So my intercept, and since it says intercept, it is written as an ordered pair, and that is 0, 0. Where does this function cross the y-axis? 0, 0. Sometimes the x and y intercept are the same thing. That only happens at 0, 0. Does it have any extrema? What was the extrema? Extrema? I heard asymptote and I forgot, and I thought I heard something else, but I don't know what it was. And critical points too, exactly. And really this says extrema, and it did this on the notes in the homework too, but the intention is critical points, right? So what were the critical points we talked about? Absolute maximum, absolute minimum, relative maximum, relative minimum, right? Now, all four of those that I just said, those are extrema. What do we throw in where it makes us have to say critical points? Yeah, the point of inflection, this thing, right? The point of inflection. So you've got the maximum and minimum, either absolute or relative, and then also the point of inflection would be things that we look for. Does this have any of that? No, there are no extrema, because if the largest, so it's none. If the largest y value or x value is infinity, that's not a value, so it doesn't count. Okay. Increasing intervals. Okay. Now remember, the only time you go to the left on your graph is when you are talking about limit type stuff or in behavior, like if x is approaching negative infinity. Otherwise, we're always moving to the right on the x-axis. So as I move to the right, my function value or my y is doing what? Increasing the entire time, right? So my increasing interval then is from negative infinity to infinity. So what's my decreasing interval? Does it decrease ever? No, so it is none. In behavior. So we have to say, as x approaches infinity, f of x approaches, and then we can figure that out. So as x approaches infinity, what does f of x approach? Infinity. As my x values get larger and larger and larger, the y values also continue all the way to infinity, so it's infinity. Then as x approaches negative infinity, f of x approaches negative infinity. So now I'm going to the left, but this is one of the very few times that that's going to happen. As x gets smaller and smaller and smaller, then my y values also just continue on to infinity. Negative infinity. Dang it, I'm sorry. Negative infinity. Sorry, still gets smaller. Everybody good so far? Does it have any discontinuities? No. So it's none. Is it even or odd? Odd. Or neither. It could be even, odd, or neither. Is it odd? Two ways we can look at it, right? We can look at it visually. If I visually want to figure out if it's odd, it has to have what kind of symmetry? Origin symmetry. If I rotate that 180 degrees about the origin, is it going to look the same? Yep, sure is. If you're unsure, turn your paper upside down. The algebraic test for that, which is what your quiz is on Tuesday, and then you have a test on Wednesday, is to replace, we find f of negative x. So in this case, f of negative x equals negative x. And then if what I get here after I simplify, which there's nothing I can do to simplify, right? If this equals f of x, which it doesn't, then it's even. If this equals negative f of x, which it does, because if I just multiply both sides by a negative 1, that's what I get, that makes it odd. Okay. Does that make sense to you? We good? Any questions at all? All right. So none of that, well, I take that back. In behavior is, I know, new wording and new concept. Increasing and decreasing, I'm not sure you ever wrote it as intervals, but I know you talked about it, especially with lines. But the rest of that, those were things that you have found with your parent functions before for sure. Okay, so let's look at the absolute value. Okay, so the name's already out there for you, so it kind of gives you a big old hint here. The parent function would be f of x equals what? Absolute value of x. Think about what's happening here. When I had f of x equals x and I substituted in an x, the y was the same, right? So when it's 3, y is negative 3. When x is 4, it's negative 4. I'm sorry. Let me back up. When x is 4, y is 4. When x is 3, y is 3, right? When x is negative 3, y is negative 3. But when you throw in the absolute value, on the positive side, you see how this is the same as that linear function right above it? But then this, instead of continuing down here, I would get all those same values, but once I took the absolute value, it makes them all positive, so it gets broken right here and just reflected in the x-axis. Does that make sense to you? Because when you change the sign on the y value, it's a reflection in the x-axis. And that's what we're doing, is we're changing the sign on our answer, basically, and we just break that line and flip it up. Okay, you see how that works? Okay. So our domain then, what is the domain for this parent function? Good. Negative infinity to infinity, because it is, oh, I was in the wrong place. Sorry about that. Negative infinity to infinity. Then my range is what? 0 to infinity, because I have nothing down here. My y can't be negative because I'm taking the absolute value, right? So it starts at 0 and goes to infinity for my y's. Now I know I never include infinity. Do I include the 0? Yes. 0 is part of my range. I can have a y value of 0. Does anybody have any question about that? Because there was a whole lot of parentheses where there should have been brackets on that quiz. But don't be afraid to ask something if you're confused. We good? Okay. What's my x-intercept? 0, 0. Good. And it's a point. Y-intercept? 0, 0. Okay. So, extrema. Do I have any this time? Yeah, I do. What do I have? Absolute minimum, right? This point right here, that's the smallest y value that's going to exist, and it's an actual value because it's not infinity. I don't have an absolute or a relative maximum. I don't have a point of inflection. I just have this right here, and that point is 0, 0, right? And then we have to say what it is. That is an absolute minimum. So write that down. This. All right, so again, I'm trying to write absolute minimum. All right. Then is there anywhere on here where it is increasing? Yes. Is it increasing from negative infinity to 0? No, because remember, we're looking at the x intervals, okay, but we're talking about what's happening to the function value, f of x or y. The y values decrease here, then they increase. So that's going to be 0 to infinity. Do I include 0? No. On increasing and decreasing, it's always parentheses. You never include any of it. So just like that. So then decreasing goes from negative infinity to 0. Okay. You want this filled out. You want it filled out neatly and well, because this is going to become a very important resource for you to refer back to often. All right, so then in behavior, so we have to start out with, as x approaches infinity, f of x approaches what? Infinity, good. As x approaches infinity, f of x is going to infinity. Is it always going to be an infinity as your answer? No. Okay, and it may be a lot, and it may be on all the ones we do today, but that doesn't mean that it's always like that. All right, and then as x approaches negative infinity, f of x approaches what? Is it negative infinity? Is it 0? As x approaches negative infinity, so way out there where you can't see, it's going to positive infinity. Good. Everybody okay with that? Any questions? All right. Are there any discontinuities? No. So there are none. Is it even, odd, or neither? even because it is symmetric with respect to the y-axis, right? It is even. Okay, everybody good with that? So we're going to come back, and not today, but we're going to come back and we're going to fill in some key points. And our key points are not even extrema and stuff like that. It's the points that when you're going to go and graph this, and I say, here's a piece of graph paper, I want you to graph the parent function for absolute value. That you don't just slop down a little t-chart and throw a V on there. You got to get a couple of key points, not 30 points, 3, maybe 5 max, so that you can get it drawn in accurately. Then we use those points when we do transformations to take those points, know where they go, and then just move them around and stretch them and do whatever, and it helps you get it down more accurately. Okay, so we'll come back and fill those in. All right, and then quadratic. So let's look at this one. Your quadratic parent function would be f of x equals what? X squared. That is a quadratic. Okay, quadratic is x squared. That is a parabola. It is x squared, right? So our domain for this is what? Good. Negative infinity to positive infinity. And what's the range? Good. 0 to positive infinity. These are the same as the absolute value function, right? It's the same thing because, I mean, this is not pointy like the absolute value function, but it's in the same areas of the graph. Okay, what's your x-intercept? 0, 0. And what's your y-intercept? 0, 0. Do we have any extrema? We have how many? Just one. So that one right there, that is 0, 0. And what is it? Good. It's an absolute minimum again. Is it increasing anywhere? Yes. From 0 to infinity. Good. And decreasing from negative infinity to 0. All right, in behavior, we have to have our little statement. As x approaches infinity, f of x approaches what? Infinity? Y'all agree with that? Good, infinity. And then as x approaches negative infinity, f of x approaches positive infinity again. Are there any discontinuities? Nope, none. Is it even or odd? It is even. Of all this stuff we just filled in for the quadratic, was any of it different than the absolute value function? Nope. The only thing that was different was the actual function itself, right? Okay, so, but it has some of the same properties there. Okay, and it's even because if we substitute it in, it would work too. Yes, sir. Okay. But it is. So the decreasing interval, way out here in negative infinity, I'm way up there at positive infinity, right? Yes, and as I know that the arrow is pointing this way, but we don't care about that. That's just to show us how to finish drawing it. But as we move from left to right on the x-axis, your function values decrease until here, and then they increase. Does that make sense? And there's a lot of people that kind of get confused about that. You're going from left to right, unless it tells you you're not, which is like this. This is when it tells you you're not. Otherwise, everything we're writing, our intervals get written left to right. Some of you had some correct intervals on your quiz, but well, it really wasn't correct in the end, but it was because it was flipped around. So make sure that you're always going from least to greatest. And there's a few little times where, like in behavior, it'll talk about it differently. But other than that, we're always moving left to right, looking at x, or having the x intervals and figuring out what's happening to y. Okay, are we good so far? Any questions at all? Okay.